Okay, so this is my final project presentation for digital forensics class at NYU. My name is John Costura, and my project is titled Magic Number Image Analysis. In its simplest form, the script I wrote will basically takes in any number of images or files. It'll process them using the sleuth kit tools, compares the files that it recovers to a magic number list in order to determine the type of file it is. From there, it will attempt to extract any kind of metadata. It'll save all this information to a database. It'll provide all this information in a text-based report, and it'll generate a pie chart showing a breakdown of what it recovered at the very end. So we'll start with the main script is magic number image analysis.py. You have your imports up at top. You got this function down at the bottom, which the only thing it really does is it looks for a help argument. If you provide -h, it'll show this usage statement here. Otherwise, it's going to go into the main function. The main function works by first checking to make sure that or some sort of argument was provided, and then it sets everything up. It'll set up a recovered files directory, which is where everything is stored. Everything that's recovered is stored. It'll set up a SQLite database and a text-based report. From there, you go into processing the arguments. It's looking for a -i to detect whether or not the argument passes an image, or a -f if it's a file. It'll check to make sure that the arguments you pass are valid, and then it'll process everything. So this process image function that gets called, and then it gets analyzed, that comes from this file project image process.py. And what that does is it sets up a new image process class. It sets up the file recovery, starts analyzing the images. This is the call to the sleuth kit in order to recover all the files first, and then we'll iterate through all the files that are recovered and process them using the file process class, which is right here. And this is where most of the main work is done. This process function here, it will take in a file name or the path, determine the base file name. It checks the file against the magic numbers list, which I'll show you right now. This is just this check file. It's going to open it into a hexadecimal format. It's going to compare it with the magic numbers dictionary, which is defined down here, and then it's going to find the best possible match. This magic numbers dictionary was compiled using the list online at garykessler.net. It's a fairly comprehensive list, as you can see. So most of the stuff will find a match. There will be files that aren't found, however, and those will return an unknown file type. For further analysis, you would have to use the report.txt file to find those files, and then you can query the database just to see if any kind of metadata was recovered from those files, even if the type wasn't determined. Okay, so back to the file process. Once it checks to determine the file type, in order to extract the metadata, it relies on this acquire metadata module that's a Linux-based module. It'll run to try and check whether or not that can find any kind of metadata. One thing that module doesn't seem to process properly is PDF data. So there's an additional check. If it errors out, it's going to check for PDF data, and if it errors out, then it's not going to find anything. From there, everything gets logged in the report. The data gets saved to the file info table along with the MD5, SHA-1, and SHA-256 hashes, which come from this simple hashing class here, where it just takes in a file and returns whatever hash it's looking for. And then it's saved to the database. All the database functionality is controlled from the final project DB class. I use SQL Alchemy, same way most of us probably did in the homework assignments, to process everything. There's the initial create, and then here's the table definition down here. So file name, the hashes, the type, calculates the size of the file, the magic numbers if any were detected, and any kind of metadata that was recovered from the file. This data is used to generate the pie chart at the very end of all of this. So let me go back to the main script. Once this is done running, it'll process all the images here, any files using this one, which just goes directly to that file process function. Once all that is done, it'll go into this pie chart analysis generation, which is this function right here. It'll connect to the database. It runs this query, which basically just calculates selects the file type and how many of those file types, and then it'll build the pie chart using the type and the count. Generates the pie chart. The pie chart is based on this PyLab module and import function, and it'll pop up on the screen, and then after that the code is done running. So now we'll move into, I got a Kali Linux 1.0.6 64-bit VM that I was doing all my testing in. We'll move into that. I got all the files copied over, and this is how you run it. You just call Python, the main script, magic number image analysis, and then pass it any number of images after a -i, any number of files after -f. You can pass just images, just files, or any combination of the two, and it should process everything. So let's hit enter. So it reports some progress to the screen. It's processing the image. These two images were taken from just the small test images that we used for the Python homework in class. I tested with some larger images, but it takes too long to run for a demonstration. So it'll report the acquire metadata module, reports if it's unable to parse anything. Just, if you wanted to go back and look at it. There we go, it's done processing. So you get this pie chart window that opens up. It shows you the type of file. It gives you the percentage of how many of the total files, how many of them are that type, and it gives you the count. Can expand it this way to show all of the counts. So, in this, there's one file found that was a newer document, Microsoft Word Office document type. There's one file found that was an older 2003 to 2007 type. A couple bitmaps, a zip file. 9 files were unknown, so those would require further research. A bunch of other files, a couple PDFs, and then mostly JPEGs in these images. And that's pretty much the extent of my final project. There's another, if you run the -h, that's about the only thing. It'll show a usage statement in order to get it to run. It does rely on all the files, all of those script files that were just explained earlier. It recovers everything to a recovered files directory based on image names, so you can view the actual files for further analysis. There should be a final project database. That's the SQLite database, which is generated with all the data stored. If you wanted to copy that off and use it for more advanced analysis or more advanced querying. And then there's the final project report file, which reports everything all in text-based format, where the files are saved to, what type of file was discovered, and whether or not metadata was found, and then any of the metadata about that file. And timestamps everything for when the program was run. And as you can see, it does a pretty good job of extracting metadata from most types of files.